This is graphing in standard form of a quadratic function, identifying the axis of symmetry, the vertex, the y-intercept, any x-intercepts, and does it open up or down. So if you wanted to take the time to write down the slide now, you could do so, but I'm going to, on the next slide, have all these steps set up. So I'd say you probably don't need to write them down right now. I do want you to write down what is standard form, just this piece that I'm circling. Standard form is f of x equals ax squared plus bx plus c. And then I'm just going to scroll through. Here are the steps for you. 1, 2, 3, 4, and 5. All right. Here's our example in standard form. We have a function. It's x squared plus 6x plus 5. Step 1 is to find the axis of symmetry. So we need to find out the line of symmetry that splits that parabola in half. So what I'm going to do first is look at this quadratic equation. The a term is the number in front of the x squared, so that's your leading coefficient, and that's 1. Our b term is our coefficient in front of the x term, so that b term is 6. And then our c term is our constant, which is 5. So for that first equation, opposite of b over 2a, or negative b over 2a, we're going to plug b and a into this equation. And say equals negative, and now our b is a positive 6 over 2, and I'm going to replace that a with what we have up above, which is 1. Now let's simplify that. Negative 6 divided by 2 is negative 3. So our axis of symmetry is that x equals negative 3. This is our line of symmetry. It's a vertical line, it's an imaginary line. Now we're going to go to step 2. We want to find the vertex, or that critical point, the maximum or minimum point on our graph. So to find that, what we found in step 1, our x equals negative 3, is our x of our ordered pair. And now to find our y, we're going to evaluate the function for negative 3. So we're going to evaluate it for f of negative 3. So we're going to go up into this blue equation, and we're going to evaluate it for negative 3. So f of negative 3 equals, replace the x with negative 3, replace the x with negative 3, and now let's simplify this. So negative 3 times negative 3 is positive 9. 6 times negative 3 is negative 18 plus 5. 9 minus 18 is negative 9 plus 5 is negative 4. So our y value is negative 4. So we want to write this as an ordered pair. Our vertex equals our axis of symmetry number, negative 3, and our evaluation of f of negative 3 is negative 4. Now step 3 is to find the y-intercept, where it crosses on the y-axis. So to find that, we're going to look for the constant. What is the constant in the equation, the c value? So let's go back up here. Our c value is 5. So this is our y-intercept. So our c value is over 0 of 5. Step 4 is to find the x-intercept or intercepts. We want to either factor the quadratic equation. If it's not factorable, we want to use the quadratic formula. Remember, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is our second choice. So let's go up to our original equation. Our original equation is in the blue, x squared plus 6x plus 5. We're going to set that equal to 0. So here's our original function, x squared plus 6x plus 5. We're going to set it equal to 0, and we're going to solve for x. These are also called the zeros of the function. So we've already been taught how to factor. In this case, it is a trinomial and our leading coefficient is 1, so we're going to use the chart method. What are the factors of 5 that add to 6? Well, they are 5 and 1. So we have x plus 5 and x plus 1. Now we're going to use the zero product property. We're going to set each factor equal to 0 and solve for x. So one of the factors is x plus 5, one of the factors is x plus 1. And solve them for x. So we'll subtract 5, and we'll subtract 1. Those are the zeros of the function. We want to write these as ordered pairs. So the x-intercepts as ordered pairs are over -5, so left 5, up 0, and over -1, so left -1, up 0. Step 5 is to identify, does this parabola open up or down? We're looking for the leading coefficient, the a value. So let's go back up to the problem. In the green, our a value is 1. And that's a positive number. So that's telling us our graph is going to open up. Our a value was a positive 1, so it's going to open up. Now let's go ahead and put everything together and graph it on a coordinate plane. So I'm just going to work backwards. I'm going to start with step 4. Step 4 was to find those x-intercepts. Those x-intercepts were -5, 0, and -1, 0. So I go on the x-axis, my horizontal axis, and I go over -1 and over -5. So here's -1, -2, 3, 4, 5, -5. I'm going to create order pairs. -1, 0, -5, 0. These again are my ordered pairs for my x-intercepts. And let's work our way up to step 3, was to find the y-intercept. The y-intercept was 0, 5. So we go on the y-axis, it's your vertical axis. We're going to go up 5 units. So here's 2, 4, 5. We create an ordered pair. Over 0, up 5. We just graphed now the y-intercept. The next thing we found was the vertex. The vertex was in the red, -3, -4. So here's -3, here's -4. We create a point, -3, -4, that's my vertex. And now I'm going to put it all together. There's my vertex. I also have that line of symmetry. I'm just going to graph that in the yellow. That line of symmetry is at x equals -3. And that's how you graph in standard form.